The content of this video, as well as the thoughts, views, and opinions expressed herein, belong to the presenter and do not necessarily reflect the views of Brigham Young University or the Church of Jesus Christ of Latter-day Saints.
We're going to try to make this worth your while today and talk about natural law and godly power, which really has to do with how the God we worship relates to the laws of nature that science has discovered. This is all under the umbrella of this question that we started out with at the beginning. Are science and religion ever compatible? And the fact of the matter is that Joseph Smith has made significant inroads in bringing science and religion into correspondence. And we're very grateful for him and all that he has contributed in the pursuit of truth. There has to be, of course, just one truth in the universe, right? And revealed religion and science have come together in the latter days in amazing and interesting ways. When we talk about science, of course, there are many branches of science, the principal one of which is chemistry. As you know, there are lesser branches of science that we should acknowledge, most of which end in the word or the phrase ology for some reason. Chemistry, of course, stands apart in that regard. I like this cartoon by Sidney Harris, The School of Ology, and you get to pick your school. Of course, the feature that all these branches of science share is that they do their business by observing the world. And those observations now in the 21st century are typically recorded and presented and organized according to mathematical measurements, what we call data. The laws of nature then are deduced from the data and the observations that result. And this is true in virtually every form of science that you can imagine. Mathematics has become an essential element to the progress of science, to the dismay of all college students. I keep kind of poking fun at our reliance on mathematics, and I don't want to offend our mathematician friends because, in fact, science is heavily dependent on mathematics, and we're grateful for our mathematics colleagues. This idea that you can describe nature in terms of mathematics goes way back to a man named Pythagoras who lived about 500 BC in Greece. Actually, in the larger Greek empire at the time, he did most of his work in Sicily in Italy, not a part of what we today think of as part of Greece. He may have inherited much of his learning from Egyptians and perhaps even from the patriarchs that we read about in the Old Testament. But the point that we would like to derive from Pythagoras' work is not so much the Pythagorean theorem that you love to hate, but rather in the idea that nature can be described by mathematics in terms of the patterns that we observe in the way things work. He actually compared or tried to model what we see in nature after what we hear in music. He looked at the scale in music and the length of strings, for example, that produce certain harmonies, and decided that that could be described using numbers. And that's one of the reasons why we have numbers associated with many of the notes, the musical notes that we may read. Mathematics originally was, before his time, confined to more practical things like engineering, accounting, practical stuff in ancient Egypt and the ancient civilizations. Natural philosophy itself often was a little bit detached from mathematics. And people like Aristotle and so on who came after Pythagoras although they also dabbled in mathematics a little bit, often used qualitative ways of describing the world, things like plants and animals and the world and so on. We've talked about the model that Aristotle came up with a couple of hundred years after Pythagoras of the world. But you know, with beginning with Pythagoras, and as time has progressed more and more, our understanding, our ability to understand what's happening in nature is described in terms of mathematics as he started this process. So about 2,000 years have gone by since that time. Aristotle, of course, described the universe in terms of the earth being at the center of the universe because it's composed of fallen and corrupt materials, which by their very nature fall to the center of the universe and accumulate there into this big ball. And then we have around the earth, or the center of the universe, the concentric spheres, these crystalline spheres that carry the different homes of the gods like Mars and Venus and Jupiter and so on. And then in the distance, we find the immovable and unchangeable realm of the fixed stars. As time went by, over the next couple of thousand years, our use of mathematics in describing the world didn't progress very much. Aristotle's model here with perfect spheres was modified a little bit over time, but you'll recall that it was in about 1500. If you want to fix on a date, rough date of when things started to change, it was around the year 1500 that people like these came along. And more math was introduced into the scientific endeavor. We started with Copernicus, who claimed that the sun rather than the earth was at the center of the universe, and Roger Bacon, who developed an empirical approach to science, Kepler, who taught us that the planets go around the sun not in perfect circles, as Aristotle had said, but rather in ellipses. Both perfect circles and ellipses have their own mathematics associated with them. And the reason that Kepler decided that the planets must be going around the sun in ellipses was because he was making very careful measurements, numerical measurements that could be associated with mathematical equations. And the same was true with Galileo, who did a lot of work in modeling the motion of objects both on Earth and in the heavens. And then comes along Isaac Newton, who kind of nails it when it comes to associating math with science. Isaac Newton is typically associated with the invention of gravity. When the apple falls on his head, that's really just a silly story. Now you'll notice that this whole thinking process used numbers. And it was Newton who took these numbers and converted them into a model of gravity, not just for the way things work here on the Earth, but all of the heavens, the moon, the planets, and so on. Remember that Newton's most important contribution was not the specific invention of gravity, but what was it? It was clearly demonstrating that the same laws of nature work on the earth and in the heavens. Remember that Aristotle had taught that the earth and the heavens obey different laws. Materials on the earth fall down because that's their nature. Materials in the heaven go round and round the earth because that's their nature. Completely different materials obeying completely different laws of nature. But what Newton is telling us here is that the same laws of nature, specifically the law of gravity, apply both on the earth and in the heavens. And that is a revolutionary idea that completely changes the way people think about the universe. So Newton's innovation is that the earth and the heavens obey the same laws. And this is one of the ways, as we've talked about over the last few days, that the Lord has revealed to us exactly how the universe is working through Newton in this particular case. Newton and math. When he published this, he didn't simply publish it as principles of natural philosophy, as Descartes had done earlier, but instead he added the word mathematical, and that's really important. That's another great innovation that Newton can take credit for. Now, I don't want to scare, if anybody feels sick at this point, close your eyes, okay? I have kind of broken a promise, and I've introduced a little bit of math here to you, but I'm not going to talk through this with you at all. We're not going to learn this in any way. You just recognize this as an equation. That's all you need to do. If you fell asleep or went into a coma because I put that equation up there, it's time to wake up because there's a good cartoon to look at. Yes, math can do that to you on occasion. Well, remember that the ancients thought that nature was controlled by gods, many different gods. And nature, I think this can be captured in this little sentence here. Nature is arbitrary and whimsical. Each event in nature is unique. Each event that happens from day to day is governed not by predictable natural laws, but instead by unpredictable gods and spirits. But that's the case now with Newton no longer. Instead, what we believe, because of what has accumulated over the last few hundred years, and you and I just take for granted, that the world operates not on these unpredictable gods and their whims, but instead on an invisible underlying order. And that order actually results from a mathematical blueprint that seems to underpin everything that happens in nature. And this is all thanks to Newton and his belief in a structured universe underpinned by natural law. The law of gravity, as you see, is fairly simple. But one of the things that I want to make a distinction here, and I think this will become clear as we explain it. What Newton is doing here is using mathematics as a way to describe nature. So that's why I say what Newton has done and what his colleagues and those who immediately followed him, they have used mathematics as a descriptor. But the relationship over time became tighter between mathematics and nature. Let me illustrate. For example, when Einstein came up with this famous equation here that simply relates energy to mass using a constant, he was unaware, or the world was unaware, of all of the implications of this relationship. And in fact, after he published this, and he gained great acclaim as a scientist for doing this, this equation underpinned the development of something that he found somewhat reprehensible. And I think you know what that is. It has to do with the conversion of a little bit of matter into an awful lot of energy in an instant. Mathematics, however, in that case was used as a predictor. In another of his great innovations, he used some mathematics one of his colleagues used mathematics in a different way. In 1928, this scientist here, whose name was Paul Dirac, realized that the equation describing an electron had two possible solutions, a plus solution and a minus solution. Now, you don't have to be a high school mathematics teacher to remember that there are simple equations that have two solutions like this. Maybe you recall in your nightmares what those might be. Like by the way, if this disturbs you and will give you indigestion after dinner, close your eyes and close your ears, and those who wish to pursue this can continue, all right? But my point here is that there is a simple kind of equation that has two solutions like this. They're called quadratic equations, and they have this simple form right here. Does this ring a bell? Maybe it rings a bell. At any rate, when you solve this equation, x, which is the variable in the equation, can have two values, either a plus value or a minus value. And that's what the more complex equations that Dirac was using, that's the kind of thing that resulted. He had a solution to the equation, and the solution, the value of the x that he was looking for, could have had either a plus or a minus result. Now, he was trying to describe the behavior of an electron. And you tell me, what's the charge on an electron? It's negative, right? Well, he's trying to describe an electron using an equation. And he comes up with a solution to the equation that has not just a negative solution, which is what you would expect for an electron, but also, on the other side, it had a positive solution. And so Dirac, having maybe more trust in his math than you and I might, decided, well, maybe there are electrons that have a positive charge. The equation predicts that that's true. I wonder if it isn't true. Well, for a few years, this was the reaction of the scientific community. Yeah, right. Just because the equation predicts a positive electron doesn't mean a positive electron exists. How stupid can you be, right? Well, the last laugh was with Dirac, it turns out, because 4 years later in 1932, positive electrons were discovered. And this, to me, is an amazing insight into the relationship between mathematics and nature. Which comes first, nature or mathematics? Are we using mathematics to describe what we observe in nature, or are we using mathematics to tell us what is in nature? That's kind of spooky, isn't it? Kind of drives you crazy. This is a very spooky idea. Nonetheless, you and I have benefited from this invention of positive electrons. If you've ever gone to a hospital and had a PET scan, because those use positive electrons to do the scan. The question then arises. This is a deep philosophical question, folks, and one that you can ponder and ponder and ponder, and you'll never come up with an answer. Isn't math just a cerebral exercise disconnected from reality? Apparently not. And it makes you wonder, if math predicts it, can we conclude that it's probably true? Believe it or not, this is the way scientists now, after this kind, and this isn't the only instance of this kind of thing happening. After this kind of thing happening, scientists are more and more prone to believe this way. If the math predicts it, we conclude it is probably true. If the math predicts it, we should go out and look for what the math has predicted in nature and see if it really isn't there. This is the way I always solve equations myself. Works every time. But this idea kind of lies at the root of a movie. Okay, what's the name of the movie? The Matrix. What's the principle behind the Matrix? It's that reality itself is just an illusion, right? And the reality is being created by some computer using mathematics. Makes you wonder, doesn't it? Don't wonder too long, it'll drive you crazy. So the question remains, is mathematics the language of creation? Maybe something to, that's a serious question that you might want to think about. Is this one of the tools that our Heavenly Father uses in his creative endeavors? So the laws of nature, they are typically and more described using mathematics. We could ask ourselves the question then, what is mathematics exactly? Well, it's really just a formal form. It's a form of logic that is very formal. It's logical reasoning, as I think my mathematics friends would agree. Modern science is subject to reason, according to everything that scientists believe in. And so is there a relationship then between the reason that we find in mathematics that's very formalized and very objective, so to speak? Is there a connection between that and our religious beliefs? Well, underlying that question, there's another one, and that is, where do the laws of nature actually come from? We recognize, using science, we recognize what the laws of nature are, but that doesn't answer the question why they're there at all. Why are there laws of nature? Where did they come from? Did somebody create them? Did somebody, is somebody controlling them? If you ask a scientist, it turns out that scientists, by a slim majority, actually believe in some form of deity or higher power who is kind of working behind the scenes and making the laws of nature work in some way or other. And I think that you and I would agree that that's true, right? That there is a God who is working to make the laws of nature work, the power behind the laws of nature, if you will. If you were to ask Joseph Smith, here would be and is his answer, and therefore, I believe, the Lord's answer to that very fundamental and interesting question. All kingdoms have a law given, and there are many kingdoms, for there is no space in which there is no kingdom. We talked about what that bizarre phrase meant yesterday, didn't we? That was an interesting thing. But it goes on. And there is no kingdom in which there is no space, either a greater or lesser kingdom. And unto every kingdom is given a law, and unto every law there are also bounds and conditions. Behold, all these are kingdoms. And I would believe, I would assert that when he talks about kingdoms, he's talking about the interesting different things that he has created. All these are kingdoms, and any man who has seen any or the least, and this is about the least, I think, of these, hath seen God moving in his majesty and power. We all look out at the beautiful pictures from the Webb telescope and the Hubble telescope, and we are awed by the immensity and complexity and beauty of the creations. And I think that's what he's getting at here. All these are kingdoms, and any man who has seen any or the least of these has seen God moving in his majesty and power. But the point here that I'd like to underscore is that unto every kingdom is given a law, and unto every law there are certain bounds and conditions. We could spend the rest of the time here talking about how there are basically two descriptors of nature in physics. One descriptor describes what happens on the very large scale of stars and galaxies and so on. This is called gravity. The other descriptor describes how little tiny things like atoms and protons and electrons work. That set of laws in physics is called quantum mechanics. And these two have certain bounds and conditions. Gravity applies to the big things, and quantum mechanics applies to the little tiny things. Here's another from D&C 88. Remember, D&C 88, we're so grateful for that section of the Doctrine and Covenants because it so beautifully captures the relationship between natural law and our Father and heaven. The light of Christ proceedeth forth from the presence of God to fill the immensity of space. The light, and we spent a whole day talking about light, didn't we? The light which is in all things, which giveth life to all things, which is the law by which all things are governed. There's that word law. Even the power of God, who sitteth upon his throne, who is in the bosom of eternity, who is in the midst of all things. Where do these laws come from? They come from our Heavenly Father. They center in him, and he is the master of these laws because they center in him, according to these scriptures. Again, if you want to pursue this further, I'd suggest that you get a hold of a copy of this book by Parley P. Pratt, and I do go into this much more deeply also in my own book as well. But we must move on. Our gift from our Heavenly Father is this: God shall give unto you knowledge by his Holy Spirit, yea, by the unspeakable gift of the Holy Ghost, that has not been revealed since the world was until now, which our forefathers have awaited with anxious expectation to be revealed in the last times, which their minds were pointed to by the angels as held in reserve for the fullness of their glory. A time to come in which nothing shall be withheld, and also if there be bounds set to the heavens, or to the seas, or to the dry land, or to the sun, moon, or stars, all the times of their revolutions, all the appointed days, months, and years, and all the days of their days, months, and years, and all their glories, laws, and set times shall be revealed in the days of the dispensation of the fullness of times. That's us. That's now. And these things are being revealed, not only through prophets, but through scientists as well. And remember that Brigham Young made it clear that the insights that scientists obtain come directly by revelation from God. In knowledge, there is power, says Joseph Smith. God has more power than all other beings because he has greater knowledge. And hence, he knows how to subject all other beings to him. He has power over all. And I would suggest that subjecting all other beings to him is a reference to the laws of nature that he governs. Well, we have talked about how the laws of nature are expressed mathematically, which is a very formal form of reasoning. But the question arises, are there things that we cannot ever understand? You know, in most other Christian religions, there is a belief in what are so-called mysteries. And this is one of the ways that our religion tends to be somewhat unique. For most of Christianity, a mystery having to do with something we don't understand, maybe about Christ, or about the miracles, or about the world. A mystery is a form of knowledge that is unknowable to us. It's not just that we don't know the answer. We don't know how the miracle was performed. It's because we cannot know. It's not because we don't currently know the nature of God in all of its aspects, but because as human beings and lesser creatures in the universe, we never can know because we are not capable of knowing. That's a mystery in most Christian religions. But to our religion, a mystery is simply something that is unknown, that we don't know now, but that we can know in the future, because we have the capacity, we have this belief that's unique, that we have the capacity to become like God, and therefore know all that he knows. And therefore, mysteries are temporary for us. They are things that are unknown. And this represents a rational theology that is much more compatible with modern science than the theology of any other religion that I know of. You'll recall that Eliza R. Snow, who wrote the words to "Oh My Father," mentioned this idea in that beautiful hymn: truth is reason. Truth, of course, is something that we seek. And the Lord has used this word as one of his names. I am the truth, the way, and the life, right? And so the nature of God is something that we can come to know. Not only that, but LDS theology is unique in another way. In most Christian doctrines, God is above or outside nature, whereas in our theology, God, the God of nature, exists in nature. How do we know that? Because in D&C 130, Joseph says this: in answer to the question, is not the reckoning of God's time, angels' time, prophets' time, and man's time according to the planet on which they reside? He doesn't equivocate. He says, yes, God lives on a planet. So he is living within nature, which is completely different from the description of God that you would find in virtually any other Christian religion. The irony here is that we have a better sense for where God is. And what's the irony? Because I just realized this the other night after speaking here with you. Remember that in Aristotle's world, we have the earth at the center and we have these crystalline spheres around the earth, and the gods, the Greek gods like Zeus and Mercury and so on, they live in these crystalline spheres. So back in those days, in Aristotle's day, 300 BC, you could, if somebody asked you, where does God live? You'd simply point up and say, well, he lives, that God lives in that crystalline sphere. You could actually point to where God lives, right? And then, of course, when the Christians adopt Aristotle's model of the universe, it's just we see the same model, but with different gods and saints and angels occupying the positions that the Greek gods once occupied in those crystalline spheres around the center of the universe. And so if somebody asks you, where does God live? You would simply point up and say he lives in the heavens, which means up there among the stars and among the planets. Well, when Newton comes along and makes the point that there is no difference between the material on the earth and the heavens, they're the same, then suddenly there is nowhere perfect and unchangeable for God to live out there. And so from that time forward, Christian doctrines typically start to evolve towards the idea that God lives in some unknowable place. I remember when I was a kid, I would talk to my friends about the God that they worship. And we actually, this was in Eastern Canada, we had a compulsory religion class in my high school, which certainly didn't teach LDS doctrine. So I learned what other Christian faiths tend to believe. And the idea is that God is unknowable, and where he is not knowable. Remember the idea of a mystery? It's a mystery. You can't know it. You never will know it. He just lives out there. He lives in some unknown place. And that was a direct result, because before Newton, Christian theology was that God lived in these crystalline spheres in the Aristotelian universe. Okay. So Newton comes along and kind of puts the kibosh on that idea, and no longer can you point to where God is anymore. Well, the irony is that Joseph Smith comes back in the 1830s and tells us, well, we do know where God lives now. He lives out there in one of those planets out there. And once again, we've brought God back into the visible, knowable, seeable universe. Just a thought, just something that came to my mind. Anyway, reason stands behind all these things. Sweet is the peace the gospel brings is a beautiful hymn in our hymn book. Faithless tradition flees its power, and unbelief gives way. The gloomy clouds which used to lower submit to reason's sway. We have a reasonable theology in our church. Science believes in the laws of nature. They come about by observation, the collection of data, and the conversion of those data into mathematics. And this idea has become more and more acceptable over time with repeated observations and peer review and the other ways to decide what's true. Of course, the laws of nature that we believe are subject to revision. And this involves the application of faith in science just as we have faith in religion, as we discussed previously. But the point I want to make here is that the laws of nature as revealed are also subject to revision as more and more is revealed. Remember that Newton came up with the idea of gravity as being a force between two objects, but it's a force at a distance. There's no, in Newton's description of gravity, there's no string attaching the Earth to the moon. So what's holding the moon to the Earth? It seems magic. It's something you can't touch or see or know what it is. And so Newton was accused of enlisting the occult in his forces of nature. Is this some kind of magic? Well, when Einstein comes along in the early 1900s, he, of course, replaces Newton's force model with something else. He kind of boots Newton off the stage and insists that you can describe what we observe as gravity holding two things together as simply a warping. I say simply. There's nothing simple about this, okay? A warping of four-dimensional space-time. Do not let that worry you in any way, but notice that he's asking us to believe in something else that's kind of hard to understand. It was hard to understand what the force was in Newton's case, and it's equally hard to understand what's this fourth dimension that he's talking about. I don't see a fourth dimension around here anywhere, but it seems to work, and so science accepts it. If you want to learn more about this, I refer you to the internet, and wish you well. But we're still stuck with some kind of weirdness. We don't have weirdness of forces now, we have weirdness of four dimensions now. Why do we keep talking then about the force of gravity and we keep teaching it to our kids in high school? Well, it's because both of these ways of describing gravity are models. Remember, we talked about how models are never the real thing. They're simply a way of describing some of the characteristics of a thing. And so we have dueling models here, and we can use either model that happens to be convenient for us at the time. They're both models, and we can use whichever one we choose. In fact, it was Newtonian forces that were used to make the calculations that brought us to the moon. Didn't have to worry about Einstein at all. This may drive you crazy, but I apologize. I can't do anything about it. So, religion and science. Science and religion, are they fundamentally at odds? No, not really. They don't have to be if you accept true religion. And so we have something of a resolution of a problem that had kind of dragged on for thousands of years in trying to coordinate and dovetail what we understand in nature about nature and science versus religion. I would sum it up this way. Mormon prophet Joseph Smith teaches a revolutionary theology in harmony with reason and natural law. He promotes the search for truth from all sources, religious or secular. In fact, Apostle John A. Widtsoe said this about Joseph Smith's revelations. Joseph taught doctrines absolutely free from mysticism and built a system of religion in which the invariable relation of cause and effect is the cornerstone. Also, the church teaches that all human knowledge and all the laws of nature are part of its religious system. Science knows phenomena only as they are associated with matter. Mormonism does the same. In his conception of God, Joseph Smith was strictly scientific. He departed from the notion that God is a being foreign to nature and wholly superior to it. And on and on. He wrote a good book. You might want to get that one. Now, we have a little bit of a mental break here because I have inflicted mathematics on you today, and I want to give you a mental break. This is an interesting story. A man and his ever-nagging wife went on vacation to Jerusalem. While they were there, the wife passed away. The undertaker told the husband, "You can have her shipped home for $5,000, or you can bury her here in the Holy Land for $150. The man thought about it and told him he would just have her shipped home. The undertaker asked, "Why would you spend $5,000 to ship your wife home when it would be wonderful to be buried here and you would spend only $150? The man replied, "Long ago, a man died here, was buried here, and 3 days later, he rose from the dead. I just can't take that chance." Well, this actually serves as a bit of a segue into my concluding remarks here. In DNC 88, we are urged to seek learning. And one of the best examples of fulfilling this expectation of our Heavenly Father is this man here, whose name is Henry Eyring. He is probably the most well-known and respected LDS scientist ever. He was the father of our current Henry B. Eyring, and he taught chemistry at the University of Utah, among other things. He is well known in the scientific community for his development of a branch of chemistry called transition state theory, which is a branch of a broader field called kinetics, which has to do with the rate at which reactions occur. Some reactions are fast, like blowing up a hydrogen balloon. Some reactions are slow. And I would like to illustrate for you the kinds of phenomena that Henry Eyring was trying to understand. Again, keeping in mind that Henry provides us an example of someone who really dedicated his life to the advancement of knowledge. So I'm going to do the typical chemistry thing here and mix some liquids together. And we'll see if we have a reaction that changes in its period over time. So we're going to see a reaction that's actually quite slow. But I suggest that all the people in the front row lean way back. Okay? So there we go. Let's see what happens here. Well, that was really not very dramatic, was it? But it just showed you how reactions can take some time sometimes to occur. I wonder if that's going to keep going. Isn't that amazing? I wonder what's happening there. I'm not going to tell you. I could, but sorry. It is? Oh, so it is. Okay. Anyway, that's kind of fun, but it just illustrates for you the kind of processes that Henry Eyring was studying and for which he became quite famous. And we can benefit by following his example in trying to see the world. Let's see, where is my little clicker? Here it is. Okay. So reactions sometimes take time. And scientists love surprises. You know, scientists are sometimes accused of wanting to make things happen just so they can raise research money and underscore the current scientific ideas. But as a matter of fact, one of the best things that can happen in science is for an experiment not to work the way you expect. Well, Joseph in the Articles of Faith tells us that if there's anything virtuous, lovely, or of good report or praiseworthy, we seek after these things. And what I want to do is spend just 5 minutes or so with you, giving you some tools that will help you decide whether a scientific claim that you might hear in the press or somewhere from a friend or on the internet, whether that claim is valid or not, whether it's believable or not. Let's see if we can develop some skill in making those kinds of assessments of scientific claims. Of course, we want to know if it's true, and we can turn to various sources, first of all, to consider any claim, whether it's in science or religion or in any other way. Fortunately, in theology, we have some pretty powerful friends who can help us decide if something is true or not. We have our prophets, and we have the Holy Ghost to inspire us. But in science, how do we know what to believe? Let's consider that question. Because in fact, out there in the world are all kinds of pseudosciences ready to reach out and bite us at any moment. There are miracle cures. There are things like cold fusion. There are perpetual motion machines that people are trying to sell you. There are things like astrology and so on. When it comes to evaluating scientific claims, there is a whole gamut of tools that you can put to use. And again, I would suggest that you might want to consider in my book much more detail than I can present here. But one of the things you want to look for is this. Is the result that this person is trying to tell you about reproducible? What does that mean? It means in science, if we're going to establish a scientific truth, that truth has to be verified in an experiment. And that experiment, if to be believed, needs to be done more than once. One-time result doesn't carry a whole lot of weight. It needs to be reproduced not only in the same lab over and over again, but hopefully in different laboratories, maybe using different approaches. And the question for your friend who makes this claim is, has that been done? Scientific claims that are really credible have undergone what is called peer review. They are published in a reputable scientific publication. And that publication needs to be a peer-reviewed publication, meaning that when a scientist sends in his article describing his work, that work has been sent out in turn to other scientists to look at and evaluate before it's ever published. Has it been published? Of course, that's a really good one. Or is it just word of mouth? Has it survived the test of time and other investigations? Is it consistent with established science? If it's a very unusual claim, then it really needs to have extra proofs that it's true. Extraordinary claims require extraordinary proofs. The more extraordinary the claim, like I can sell you something that will run the electricity in your house for the rest of your life, and you'll never have to pay another electric bill. Well, that's an extraordinary claim. I mean, if they had offered you a 10% reduction in your electricity, that's not quite so extraordinary. But to say you're going to get free electricity for the rest of your life, that's pretty extraordinary. And they better have a pretty extraordinary set of proofs before you ought to hand them your check. Beware professional doubt mongers. There is a tendency among those who want to sell you an idea. It doesn't necessarily have to be a thing. It could be simply an idea. It is a trick that is used called a false equivalency. It works this way. There is one scientist who claims that this claim is true. Like there is a miracle cure for cancer, okay? And there are 10,000 scientists who claim that it is not true. But you are watching the news, and on the news you see two talking heads. One is this guy, and the other is one of these guys. And the impression you get is that there is a false equivalency, that the weight of argument by this one scientist is just as valid and just as to be accepted as the weight of argument of all these other scientists as well. Just watch out for that kind of thing. because more often than not, you'll find this guy has an ulterior motive of some kind, which is usually that thing right there. There is a book that I would strongly recommend. Every person in the world ought to be required to read this book. It's called Merchants of Doubt. It gets into how it has developed over the last several decades a whole industry of people whose full-time job is to create doubt in correct claims and underscore incorrect claims. This whole industry got its start really with the establishment in the 1950s of a scheme among tobacco companies to mislead the public into thinking that there was no harm to be gotten from smoking. In fact, this is a real advertisement from a magazine touting the fact that this doctor recommends that you take up smoking because it will be good for your health. And in this book, it goes through a number of textbook cases like this, of how there is, as I say, a kind of industry out there to try to mislead people into believing things that just aren't true. In fact, it took, this created unnecessary confusion in the minds of the public for decades. It took until, let's see, it took until the early 2000s for the tobacco industry to finally own up to the fact that cigarettes and smoking cigarettes and tobacco products cause cancer. I love this quote from Robert Park, who wrote another really interesting book called Voodoo Science, that again I would recommend. These are all light reading kinds of books. They're not scientific books, okay? At any rate, he says, there is, alas, no scientific claim so preposterous that a scientist cannot be found to vouch for it. There are, of course, hundreds of thousands of scientists in the world, and scientists are just people, just like everybody else, and scientists can be wrong. So just watch out. Voodoo Science, good book. The antidote to this, of course, is education. And the better our education and the more education we have, the less likely we are to fall for false arguments in favor of some false scientific claim. Well, to sum up, are there conflicts between science and religion? I would say, of course, that there are, and there are some remaining conflicts or apparent conflicts between even our religion and science. But one of the things I hope that we have achieved over the last few days is to illustrate how, even though there were apparent conflicts in the past, maybe 100, 200 years ago, that as time has gone by, several of those conflicts have now been resolved, and in every case in favor of LDS theology. I would humbly assert that among religions, the theology of the restored Church of Christ may be the most compatible with science of any day. That's me. Okay. Since we're at the end of the semester, we need to review for the final exam. So just as a review of the things we've covered, God's universe is beyond comprehension in scope and grandeur. That was our first day. Light refers to a particulate substance that goes far beyond the light we see with our eyes. It powers and governs the visible cosmos. Both science and theology teach of worlds hidden from our natural senses, but are as real as anything we can perceive. That was our third day. And today we've learned that LDS theology is rational and harmonizes well with the scientific approach to truth. Who's catching up with whom? As you've looked at the stories we've told, it's clear that the person at the front of the group here is Joseph Smith. Are there remaining apparent conflicts between science and religion? Sure, but the cosmic veil is being drawn back even more as we speak. And as that happens, I have faith that these conflicts will be resolved. Here's your final exam. what's the answer? It's C. The olive leaf. Well, you have endured to the end, and you can be proud of yourselves that you now are graduates of the, oh, that's cool. We're going to end our time together, not with a whimper, but with a bang. And here comes the bang. I think I'll pass on those. Thank you. Okay. Let there be light, and let there be no light. So, with this, I pronounce you all graduates of our course in Education Week this year. May you remember some of these things, and may you all enjoy happy and healthy lives.